Okay, so in the last video, we took a look at the real number system, and here it is. Here's the real number system, where we have natural numbers, whole numbers, integers, rationals, and irrationals. All of these make up what's called the real number system. And I'm showing you this because we're going to take a look at it in just a second, okay? Before I get to that, I'm talking today, we're going to talk about what are called complex numbers. Okay, what is a complex number? Yeah, we'll get to that here in a second. First, I want to answer the question, what is the square root of -4? And when I ask this in class, a lot of people say -2. And I like that as an immediate response, right? Because you think -2, that's where the negative comes from. Everybody knows the square root of 4 is 2, right? Because 2 times 2 equals 4. However, -2 times a -2 is a +4. The square root of -4 is tough, right? That's really tough. Let's take a little bit back a step here. Let's think about the square root of -1. The square root of -1. Is there a number times itself that's going to give you a 1? Sure, 1 times 1 is 1. Good. Now, is there a number times itself that's going to give you a -1? Well, no, we already know that this is impossible, right? The square root of a negative number we know is impossible. In fact, we say that it's not real, and it's true. These are not real numbers. Just some exercise that I like to do whenever we do this, just to remind ourselves, right? 3 times 3 is 9. -3 times -3 is 9. And it's important to remember this because positive numbers times themselves are going to be positive. Negative number times themselves is going to be positive. So the square root of a negative number, like -4 or -1, is impossible with what we know in the real number system. So let me introduce something here to you. We have a definition, and it's called the imaginary number. Imaginary number. Now, you might be thinking math is supposed to be concrete, real, it's all based in logic, and that's true. It is. It is based in logic. And imaginary numbers have a very solid definition, and they're very logical, even though the word imaginary makes you think, oh, these are Shrek-like numbers. And you could play like that if you wanted to. But the imaginary number is defined as I, and it equals the square root of -1. And that's really all we need, right? So here's the definition of the imaginary number. I equals the square root of -1. Here's where you're going to get upset with me. My I's look like J's, but they're backwards. And, and I don't write it as I because that looks like a number 1 with a little accident. And it's not. I. So I put a tail on him. So I equals the square root of -1. Now, let's take a look at the square root of -4. Let's revisit him for a second. The square root of -4 is really the square root of -1 times 4. And as you know, we can take these products and split them up, right? So here I get the square root of -1 times the square root of 4. And we know the square root of 4, right? The square root of 4 is just 2. And now we know the square root of -1 because the square root of -1 is I. So here, the square root of -4 is 2I. We could play this game all day, right? I could take a look at the square root of -64. That is the square root of -1 times 64, which is the square root of -1 times the square root of 64, which I know that is going to give me 8, right? The square root of 64, 8. Square root of -1 is I, so I get 8I. You do not have to do this step here every single time. You don't need to do this every single time. You should be able to say something like the square root of -25 is 5I. Or the square root of -169 is 13I. Okay? So this is the imaginary number. The imaginary number is the square root of -1. Now, what does that mean about complex numbers? Well, let's take a look at our real number system here. Our real number system is actually a subset of the complex number system. So outside of the real numbers, we have what are called complex numbers. A complex number is anything in the form, so it's anything in the form of a plus bi. All right, a plus bi. Where a and b are real, so it could be anything in here, and I is the square root of -1. So some examples of complex numbers. Let's shout out a number. Good. 7 plus 2i. Good. -3 plus 4i. Good. All great. Good examples. Oh, good. I like that one. 25 minus 6i. Now, when it comes to these complex numbers, and let's look at these three examples here that we just had. Right, the real part, what's called the real part, that would be the a value, And so here we have 7, -3, 25. That's considered to be the real part. The imaginary part is the b, whatever is being multiplied by I. So here, the imaginary part is a +2, a +4, -6. Okay, so let's take a look at some examples. Let's take a look at some examples here. Let's say we have, 6 minus I. The real part is a 6, just a 6, right? And the imaginary part, well, what's the number in front of I? That number in front of I would then be -1, right? Let's do a couple, 2, 3 more. Let's say we had, I don't know, -4 plus 8i. All right, -4 plus 8i. So the real part here is -4. The imaginary part here is a +8. Now, let's take a look. What if I just had like 21i? What about the number 21i? This complex number with the real part for this, so what's that number here in front? There you don't see one, and neither do I. So that real part then would be 0. The imaginary part would then be the +21. And the converse of that, what about 7? The real part for the number 7 would be considered 7, and the imaginary part would be 0. Right? 7 is the same thing as saying 7 plus 0i. Wow. Think about that for a second. You didn't know it, but the number 7, that's a natural number. You started with that when you were counting. It's also a whole number, an integer. It's rational. So we know that it's a real number. But as we just saw, the number 7 is also very much a complex number, because b, in this instance, real, 0 is a real number, right? So b, when b is 0, then we're left with something like 7. So 7 is in fact considered to be a complex number. We don't start with that idea, but now that we know it, 7 is a complex number.